Alright, hello and welcome back to my 2.5D RPG in Unity tutorial. Today we're covering the third part of our little bit on serialization, so we're going to be recreating the world from the data we've written to file. So first off, we're just going to create some data that we can then save, and then we'll reload and that'll prove that the fucking thing works. So first off, as you can see, we've got 2 quests done of the gone shopping instances because we have bread and water in our inventory. We'll also just quickly look at this container here. We'll see that the first 5 items are antidotes, and then it's a water, bread, and another antidote. So we can see that. We'll see that that is consistent once we've reloaded the scene. Next up, I'm just going to drop some items here to make it so that we can see that the items persist. Next up, I'm going to kill an NPC. Or this one here. So we can see he's dead now. And finally, yeah. So I'm going to press T to serialize this. So all the data is now written to the file. So if we stop that, and then we can go to our test. No, it's a load testing scene. Basically, this is just like as a. Basically, it's just a temporary menu screen, but not really. It's just like somewhere I can load from that pretend it's a menu, so it recreates the entire game from scratch. So I just press A to call that, and as we can see, we've got our gun out still. It has created another assault rifle. I'm not sure why, so I will work out why that is and fix it for next time. But as you can see, we've got the bread and water where they were. We press X, and we see that the 2 gone shopping quests are still done. If we go down here, we will see that NPC is still dead. And finally, if we go over to the container, we have to unlock it again because apparently I didn't remember to serialize whether a container had been lockpicked or not. But I will. Doesn't matter anymore. That'll be something to add once we've decided to fix this up. So yeah, we can see that this container again has 1, 2, 3, 4, 5 antidotes as the first items. The first 5 items, then a water, a bread, and an antidote. So I can see that it's serialized. So yeah, let's get on to how this was done. And it'll be a pretty long episode because there's quite a few different minor changes and then the serialization. So yeah, let's get to it. So first up, one of the things we've added or changes is repeatable conversations. Because basically, you know, like in something like Fallout where you talk to a merchant multiple times and then you bring up the same conversation dialogues. But basically we've done that so we can repeat conversations as long as the condition is true. So as you can see, basically it's just done by a public bool here, whether it's repeatable or not. And we also need to store the starting choices and the starting line. Again, so these are just set in awake, so starting choices equal to current conversation choices on awake. So, and then the starting line store is equal to the starting line. This is basically just so when we reach the end of any given conversation branch, we can just reset to these choices. And we got a new method for reset conversation choices, which is where is that? I think that's set on the exit of conversation or something. Well, it's set somewhere. We can actually just find out with find references. Yeah, when the combo stops, that's just basically called. What that does is it just goes through all, or once the conversation is done. So if the combo is done and it's repeatable, and we're not currently drawing the conversation, then we get a list of restart choices, which is a new list, and then we go through all the starting choices. And if those are repeatable, so say like normal ones, like say opening an inventory or starting trading or whatever, those ones will be added. But say if you add quest specific ones which shouldn't be added after they'd been finished, then those wouldn't. And then we set the current conversation choices to be equal to the restart choices, and set the combo done to false, and set the starting line to be starting line. We clear out the last selected and set the combo done timer to 2.0. So that's basically just resetting the conversation to its starting choice, to its starting choices minus any that lines are repeatable. And similarly, we've got in each conversation line, we got a method that isn't repeatable. So our method bool that says whether it's repeatable or not. So that's just checked. I believe, yeah. So c.repeatable, that's just the line that's checked. And similarly, in like something like turn hostile, because if someone's trying to kill you, they aren't going to want to talk to you. So we basically just get the conversation manager, and we set the CM to be repeatable to be false. So once the NPC is hostile, then they won't talk to you. So I'll just demo that. So first off, go to here, press E. We choose the first option, sure why not, because you should go by loud or quiet. And then we can see that we can bring up the same conversation again. So we can repeat that, go back, it'll stop displaying, then we start, and then, but if we go to, no, I'm not cool at all, and I can't afford it, sorry, then the dude tries to kill you, it closes, and if we go to him and press E, we can see that now we can't actually do anything. Can't talk to him because he's trying to kill us. Isn't that lovely? Another small change to the conversation manager I made was addition of, where is it? A human stack controller. This is basically just the human stack controller of the NPC you'll be talking to. It's set here, and we use it for basically to check if HSC, our health is more than 0, then we allow only normal like input detect, movement convo stuff. But if the human or the NPC's health is less than 0, or less than equal to 0, but it will be draw combo will be equal to false, so that'll just basically stop the conversation once the NPC is dead. So if we just press play here, I'm just gonna have to get a weapon for this, aren't I? Hopefully there's one in this container. But yeah. So basically we'll be able to show that once the NPC is dead, it'll stop the conversation. So thank you for that rifle. I'll use that. I press E, show why not. Actually no, I should probably do the oh shit. I fucked this up. But yeah. I fucked up the display, but yeah, you get the idea. So yeah. Next up, I just made a change to the Object ID Manager, where it'll now call refresh IDs on awake rather than start, because it's just to basically make sure that for serialization, it'll make sure that it has all the IDs ready for the serializers to reference it. And I believe I added this to the script execution order. Yeah, so on the script execution order, I've reset the order of a couple of things. So Object ID Manager will go first. Then the serialization controller will do. So basically the serialization controller will be able to reference all the IDs in the Object ID Manager, because that'll be full. Then the world builder, then create nodes and time maps, then everything else. So this script execution order basically just gives certain scripts priority to be executed first. So in this case, we're doing Object ID Manager to make sure that we have a reference to all the object IDs. And then it's serialization controller and whatnot. So yeah, that was that. Alright, you'll see now that quests have actually had their names set in the inspector. So as you can see, they're no longer, the quest name is no longer set here. This is basically just so we can have like the same quest book for unit names, like if you're Radiant quests or something, I don't know. But yeah, there was a problem with serializing it when it was just doing it by the script, so I decided to switch it to just using the inspector to set the names, and that solved the problem where it couldn't find quests when deserializing. So yeah. Yeah. So another thing is on this conversation trigger turn hostile is that it now uses the item database to get an item. So it gets the item assault rifle. Oh god, what have I done? Nope. So yeah, instead of using the test input prefab, it's now using item database to get the item. I probably should do a check to see if there is an item in what is it? What's the word? There is like already a weapon in their inventory, so I could do that instead, which will probably come in another episode, but it's not too big of a priority. But yeah, just so you can see that it uses the item database to set the weapon. And maybe what was creating the extra weapons. Well, probably not, but whatever. Next up for the quest serializer, I made a small mistake where I forgot to add a semicolon to the end of when the quest counter was serialized, which stopped it being split correctly and meant we couldn't work out what objective the quests was on. So we basically just added a quest thingy here. I'll zoom in a bit. But I basically just added a semicolon to that string, and that's pretty much solved the problem. Also, in the quest display GUI script, we basically just added a quest check method, which basically because sometimes quests weren't being added to the list of active quests. So it basically just checks it goes through all the quests that are in the global quest store, and it will check if the quest has been started, but it's not been failed and not completed, and it's not in the active quests list, then it'll be added to the active quest list. And there's a fucking Hoover in the background. Shit. Okay, so next up is the effects database. This is just basically a script where we can pass in a string array and a human stack controller. And what we do is we go through each of the strings, and we call this add effect method with the human stack controller. And what that basically does is it will check for matching strings to effects. So in this case, we've got poisoned, bleeding, and toughness. And if either any of these strings match, it will then add the appropriate effect. Pardon me. And yeah, the reason and for like simplicity's sake, so we can just pass in all the split strings, it will just filter out any that don't match and just do nothing. So it might be like in a tiny, minuscule way, a bit less efficient, but it's a lot easier to program and understand. So yeah, that's why I've done that. And that is set up on the databases. Yeah, database is just a child object player. We've got our item database and our effects database, and again, the effects database is just used when deserializing effects that are on NPCs or players. Okay, so next up we have the item database, which we did make a couple of episodes ago, but we only had up to here, just declaring it. So basically now we've got a list of all the game prefabs, which will basically just be items that are in the game. I'll show you in the inspector. In this case, we've got water, the weapon, bread, antidote, and ammo. And what we can do with these is we have two methods. So one is Populate Container, which again, like similarly to the effects database, we can just pass in an array of strings and it will filter out ones that don't match an item. So it won't do anything, and that's good. And then it'll basically go through all the strings. It will call this getItem method, which basically returns the game prefab with the item script and the name that matches the string. And if G is null, then it won't do anything. Otherwise, it creates an instance of that item by instantiating it at in this case, the container's position and the container's rotation. And it will set the item to be the item's parent to be the container's game object. And if the item has been added to the container, then we set the object to be not active anymore. Because I think I was having some trouble with that. Because it would just like add a weapon. Or I just have like a second weapon displayed on an NPC when we load them in, and I'm not quite sure why. So that worked as a fix, but it might be contributing to the extra weapon that's appearing or getting created. So I'm not sure. Anyway, next up we have populate items in world. Again, a similar principle. But remember, I might just open up the serialization controller. Oh, actually, no. Well, basically, what gets passed in is an array of strings into populate items in world. But these strings are basically the name of the item, a semicolon, that should be. Then the position of the item. Actually, no, it should be a comma, shouldn't it? Is that a split? Sorry. No, shit. No. Yeah, sorry. It probably is a semicolon, yeah. So first we've got the name of the item, the position of the item, and the rotation of the item. This is basically just creating items that are dropped in the world. So first off, we split the data with the normal split of the serialization controller. So that's by the semicolon. So name, person, brought, I'm assuming they're all split by the semicolon. And then we get the item. So in this case, we're using split data 0 because that will be the name of the item. If the item's null, so we passed in something that isn't an item, then we do nothing. Otherwise, get the position by parsing the rotate position from the split data 1. We get the rotation by, again, parsing data rotation from split data 2. And then we create the item in the world and set it to be active in the hierarchy. And finally, for the game object getItem, we basically just pass in a name. We go through each of the items in the game prefab list. We get the item script off that item, or off that object, game object, And if the item name is equal to the name we've passed in as an argument, we return the item. And if we get through all the items and we've not found a match, then we just return null. And finally, for a get random item, this was just used in the like when we were wanting to just populate the world so we could have some data to show. It just returns a random item out of the game prefabs list. Just a quick addition to the container class. We've got a new method that returns an item called getItemFromContainer. It takes a string and basically just goes through all the items in the container and checks if it has a specific item. So if the names match the argument passed in, then it returns that item. Otherwise, it just returns null. And this is used when we are equipping weapons to the player, but not the NPCs yet, because I forgot to add that in. And so I will do that next time, maybe. It's not too big of a thing, so it can probably be on the back burner for a while. And I don't want to have any like extra bugs or any bugs at the moment. So yeah. Okay, so next up, I've added a boolean to the objective-based class called objective_done. The basic idea of this is to provide a way that we can just force an objective to be done. So this is pretty useful when we're like reserializing the quests and that. So we can just say, rather than finding some convoluted way to make the objective done when we're loading, we're just going to force it to say, all right, if objective done is false, then we check. But if objective done is already true, say like when we loaded it, then we just return true without having to have all of that done. And yeah, and that's just been changed for all the objectives. So it'll have, if objective done is false, then it'll have the original is objective done condition, which will then set objective done to true. But likewise in the quest deserializer, it'll just set these method booleans to true if it is required. Another thing we've added to objective base is a virtual method to pass in IDs of particular items or NPCs or whatever that relate to the objective. So in this case, we're just passing in a string, and the working example I have is for the objective kill someone, where we basically just pass in the IDs, and that just basically sets the target to be the get objects by ID and IDs. The ID was passed in. Again, you could have more by, say, having it in a different format, like splitting up different IDs by semicolons or whatever characters bloody you like to use. And you could do that instead to have multiple. So yeah, just quick. Okay, so onto the actually meat of the episode now, so which is to be dealing with the actual serialization. First thing we've added is a load screen method to the serialization controller. This is basically just CManager.loadScreen, but with a few additions. The first is we've added a from menu screen, which will become important later, but I'll not describe that now. Basically means if from menu screen is false, so say if we're like transitioning between one section of a level, before that new level is loaded, we'll store all the data about the current level we're in. So we'll just automatically do that. And I believe, I might just find references there. On player level transition data store, we basically just said instead of using CManager.loadScene level to load, we use serialization controller.me.loadScene level to load and true. Because I believe that would be from the menu screen. Yeah. Yeah, probably right. Well, yeah, so once we transition from one scene to another, it'll actually no. That should be false. False. Yeah, sorry, that was wrong. That should be false. Because we travel from one scene to another, not from the menu. Right. And then it just sets from menu to be equal to from menu screen because it's used later. And then we just call load scene. So the next little addition we made to the serialization controller is this on level finish loading method, which takes a scene and a load scene mode argument. And it also has these, which is on enable, which these are basically just Unity methods and a delegate. So on enable is called when the object is enabled, on disable is called when the object is disabled. And CManager.SceneLoaded is basically just a list of methods, or it's an event, so when scenes are loaded, it will call all these methods within this delegate. I think that's what it's called. So we're just adding our own method to that. In this case, our method is on level finish loading. So if you hover over it, you can see it's an event that needs to take a scene and load scene mode. It's a delegate. Yeah, sorry, I was right. And basically what we do is this basically just calls all the, it basically just loads all the data for the scene that was loaded. So if the scene name is not equal to load test scene and load disable is false, load disable is just a boolean that I added to stop loading just as a debug thing. It's not actually used. You don't need to worry about it. So this is just debugging stuff, so we don't need that. Read data, we call, where is that? Read data. Basically, instead of having one list of strings, we now have multiple. So we've got player data, NPC data, container data, and you get the idea. Basically, everything's split up into its own unique list based on topic. And we also have conversation data because I added a conversation serializer. So yeah. Basically, it will go through the files of the specific data and add it to the appropriate list. And then once you get back to here, we'll also call refresh IDs just to be to get rid of ones that might have been in the previous scene and add new ones that'll be in the next scene. And I'll just debug that because we don't need to learn about the quest count. And here's where from menu comes back. If you remember that it was set here from menu screen. So if, say, from menu is true, we want to load the information about the player in the scene because the player instance won't exist in the world yet. However, if we were transitioning from one scene to another, we'd want the player to appear. The player wouldn't get destroyed because it's got a do not destroy on load thing attached to it, or call. And then its position gets set based on the entrance to the level. But if it was from a menu, then we just call the player series.parsFromString with the 2 bits of data from the array, whatnot. And then we set from menu to false. And then finally, we call the various deserialize methods, which are horribly named, which I probably should have kept consistent, but whatever. Basically, all these methods just deserialize the data. They take in a string array, and we just pass in the lists that we had converted to an array. So yeah, that was that. Okay, so first up, we got a new serializer. Oh, sorry. A new serializer to serialize conversations, basically. So what it does, finds all the conversation managers in the scene, go through each of these, we'll record the starting line and the last selected, and store those with semicolons between them. It gets a string for choices made, and it will go through each of the conversation lines in the starting choices, and we'll add this get choices, which takes a conversation line, and then it will just add this string to the serialized data. Now, what this get choices does is basically just it'll get the conversation line. If the that particular line has been done, it will add it to the return value, and then for any lines that would get added after this choice has been selected, it will call itself with that, so it's recursive, and it will add these get choices to that. So basically what it does, it creates one long string of pretty much every choice in the conversation that's been selected, and it'll, well, like every choice in that particular branch of the conversation, but each branch will get called from the starting choices, so everything eventually gets added to this string for the conversation if it has been selected. If it hasn't, then it won't be. And then that is just added to the that is just written to the file. Then on the deserialize, so when we load conversation from data, we get all the we take in an array of data, just a string. We find all the conversation managers in the scene. We go through each of the strings in the data. We split it up into multiple into an array of strings because again we've got the actual bits of data separated by semicolons, And we get the starting conversation line to be equal to, which again is just the first element of the array, like we did last time. So it'll be this bit. So the start line store is just the literally just the first line of the conversation. And we use that to find out which conversation manager it should be. So we go for each of the conversation managers, and if the conversation starting line is equal to the starting line we had written to the file, then we set my conversation to be equal to CM. And then, so if we can't find a conversation to do that, so say, I don't know why, or if just in case there wasn't one, then we do nothing. Otherwise, we go through each of the conversation lines in my conversation.starting choices and call this check choice method with both the line and the conversation. Well, they're actually the choices made. Oh yeah, string array of choices made. So these here, this is basically just the split array of conversation lines. So if if a conversation like choice has been chosen, it will be in this array of strings. And what this does, it goes through each of the choices made, and if one of those bits of strings matches up with the text of the line, the text of the conversation line, sorry, then it will set the conversation line to be done and break. And then for each of the conversation lines in cl.newChoices, then, oh, sorry, break, yeah, break, hold on, sorry, just checking. Yeah, break just closes the loop, you know, it doesn't return. Sorry, I just got confused for a second. So again, once it's found that the right one, then it'll do true, got true, and then for each of the conversation lines that may come after, it'll again call this method for CL2 and choices made. So similarly to how we actually got the data on what conversation options have been selected, we basically just we basically just check if the choice has been made, and if it has, then we just pass in the new conversation line and the same array of strings that we passed in initially, and that will basically go through the entire conversation and basically set whether a conversation choice has been made or not. Okay, so next up we've got the container serializing. Basically we've got this deserialized container data, which takes an array of basically this will be all the containers in the world and all their inventories, and each container and its inventory will be a separate line in the array. And what we do for each of those is pass the strings one at a time into this parse data from string method. I'll just show you in where is it? At the bottom. We pass deserialized container data, and we just pass container data to array. And then that is called, well, basically just splits the data with a semicolon. So now, since we've split that initial string we passed in, we've now got an array of, it'll be the container's ID, and then a list of all the items in the container. And then to basically simplify the adding process, we just use the method we created for if the particular object has a container script on it, just in case it didn't for some reason, then we add, if it doesn't have one, we do nothing, but if it does, we get that script. Well, if the object we found is null, we don't do anything. But if the container is true, if we do have an object, then we get the container script of it. And then if there's no container script on it by mistake, then we do nothing. Otherwise, we pass it into the item database.me.populate container, which again is just well, like I said before, it takes the array of items and the container, and it goes through the array, and if a string in that array matches an item, it will add that item to the container. It's actually pretty simple for the item serializer. Basically, we're doing it even similar to the serialization controller, except we can just pass in the array straight into the item database.me.populate world, populate items in world. We could have just called this method directly from the serialization controller, but I thought it was kind of neater and kept with every other serializer, so it was easier to understand, I guess. Pardon me. So yeah, populate, basically this will just be each line of this data array will contain the name of the item, the position of the item, and the rotation of the item, and then that is just created in the world. As is. Well, it's basically just created in the world using this populate items in world method, which we've gone over earlier in the video, so you can go find that and I won't explain it again. So next up we have the player's serializer. So we've got the parse data from string. This one, instead of, since it's only 2 strings, instead of just an array, we pass just the data in it separately and inventory data in separately. Again, this is just done from player data 0 and player data 1, because the maximum number of lines the player data will be is 2. That's how we should do that. First off, we split the data by with a semicolon. Then we find the player object on the screen in the scene. Sorry, just by using the player tag. Then I think I had a. Did I have a description? No, I'll have to just bring up the example in this player info. So I'll open that with Atom. Oh, it's a different version of Atom. I picked the wrong one. Yeah, sorry, I'll just bring this up so I can show you what it looks like and how that translates to the array. Load, you prick. Come on. It's a text file. Okay, let's try loading it with something else. Open with text it there. There we go. So, yeah. So what we do is we load Plague Desert. So basically, the first item in this data array is the play. Oh, sorry, getting ahead of myself. This is the data string that is passed in, and this is the inventory data. So we split the data by strings and split the initial string by the semicolon, and then each of these items becomes a string. So we ignore 0 because that is just the scene name that the player was last in. So we'd need to probably store that somewhere else, like outside of all the different save files for different scenes, so we can what's the word? So we could know where to load the save game in from. But yeah, so the first element of that array is the position of the player in the world. So we use the serialization controller there to parse that from the first element of the array, and again the rotation is the second element, so we parse that, and then we just assign it to the player game objects we found. Next up, the weapon that was currently equipped is the fourth element of the array. Yeah, fourth. So that's there, and then the amount of ammo in the weapon is the fifth element. We have a marker for stats as the next element, so we just skip that. So that'll be the sixth element. Sorry, and then the seventh and eighth is just health and max health. And then after that, we can have what's the word? Just like effects for the player. But in this case, we don't have any effects serialized, so we don't do any. And next up, we can basically just populate the container using the item database .populate container method by passing in the split from first and player. Actually, wait. No, passing in the wrong bloody string. Sorry, missed that. We should be passing in inventory data. And the player.get component container. So that basically allows us to use the same method for adding items to containers, NPCs, and the player. And if the weapon is not equal to no weapon, because I remember no weapon is just what's the word? Just a way of marking that we don't have a weapon equipped. Then we get the particular weapon from the container, and then we get the weapon controller from the player. We set the weapon to be the new item that we found from the container, and then we set the ammo value to be the correct value. Finally, we get the human stat controller of the player. We set the health to be equal to the health value, max health equal to max health, and we use the effect database.me to add multiple effects to add the various effects. So we pass in split from first and the human stat controller, and that basically just goes through checking for strings that match effects in the game and then adds that effect. Okay, so next up we have the NPC deserializer. So we call this parse data from NPCs, and basically each of the elements in this NPC data array that's passed in will be something like this. So it'll have an ID, whether the NPC is dead or not, and the weapon, its ammo, position, blah blah blah. And yeah, and then we will recreate the NPCs from there. So first off, we pass in a string and we split the data by the semicolon. So now we have an array of the NPC's data, which is all basically just all these elements of the example. First off, the ID is the first element, so we do that, and then we use the object manager get object by ID. If the NPC is null, then we're saying, all right, we can't find it, don't do anything. But if not, if there is an NPC by that ID in the scene, then yeah, then we keep going. If the next element, so the second element in the array, is dead, which in this case it'd be true because that was an NPC we killed, we basically just deal 999 damage. And call it a day. Otherwise, if the NPC is not dead, then we parse our position from the 5th and 6th elements of the array. And remember, I'm saying 5th and 6th, but it says 4 and 5 because arrays start at 0 and it's a pain in the ass, but I know. It's just kind of confusing to say 5th and 6th, but whatever. So yeah, so the 5th and 6th element of the array is the position and rotation respectively. So we parse them using the serialization controller, and then we just assign the position to the game object. And we have this method called add action to NPC, which will take in the 7th element of the array, which should be the NPC's action, but in this case you can see it's none. So it has no action, so otherwise, but as you can see, we have a method here. It basically just takes a string for the action and the NPC game object. And if action is equal to follow player, we add the action to be follow player. If it's roam map, we roam map. If it's hunt player, we hunt the player. That's pretty much it. And then if we've added an action at the end of this, then we just do call npc.replace current action with the new one that we added. Then we get the container off the NPC and just call the populate container with all the data we had from this array of data about the NPC. And then I don't think we actually have. Do we have to do this? Oh yeah, sorry. Yeah, basically what we had to do was work out where this stats header was, or it's not really a header. Isn't it's basically just to mark out where the stats start, so we can know where the inventory stops, where the stats begin. So we work out what index that stats string is. So we know that the one after that one will be the health value. The one after that will be the maximum health of the NPC, and then any other strings after that will be effects. So I basically just have to start at 0, we go through the array of strings, and if stats is equal to the current one, then we set start of effects equal to x. And then we can get the health by using int.parse, split from first, start of effects plus 1, and then max health is int.parse, split from first, start of effects plus 2. And that's how it works. We get the human stat controller as well. We set the health and max health there, and finally we pass it into the effects database to add multiple effects. Again, we can just pass in the entire data array while being slightly less efficient It's simple, so it's good. And then that'll just add any respective effects we need to the NPC. Next up, we have the quest deserializer, which basically goes through all the elements in the quest. Sorry, all the elements in the quest? All the elements. Sorry. Oh, miles away today. It takes an array of strings, which basically contain the quest and all the done objectives, an index saying what objective we're up to. And it will then call this parse data from string method, which will dismantle those strings in that array and set the quests to be the value that is needed. So first we split by the semicolon, so it should just be the quest name, the current quest index, so what objective we're up to, and then after that, if there is anything, there will be IDs relevant to the current objective. So quest base, current quest is null, quest name is the first element of the string that's passed in that we just split up, and then we go through all the quests in the global quest store, and if the quest name in q.questName is equal to the quest name that we got from the file, so I'll split in the string or whatever, then we set current quest to equal to q, and we stop going through the loop because we're good, we found our quest. So if the current quest is null, then we don't do anything because the quest doesn't exist, or we've done something wrong. Next up, we get the objective counter, which we just get as a int.parse from split from first, and then we just declare the objective base for current objective to be equal to null, just for now. And we go through each of the objectives. So for int x equals 0, x less an objective counter, x plus plus, we go through, we set the current quest dot objectives in quest dot x to be true. So we set it to be done basically. So this will force the objectives to be done. And if so, this next bit is, what is it? Basically just sets whether the quest is finished or not. So if there's only one objective in a particular quest, then if the objective counter is equal to the current quest dot objectives in quest dot count, then we set the quest finished to be false. Otherwise, we set the current objective to be the objective in quest objective counter, and then we set current quest dot current objective to be current objective, to be the current objective that we found. And we have a slightly different one for if a quest has more than one objective. So if objective counter equals current quest dot objectives in quest dot count -1, then quest would be finished equals true. And then if it's not equal to that, so it'd be less, then we just go through all the sorry, fucking knackered. So we get the current objective, which would be the objective in the quest at the objective counter. Then we just set the current quest dot current objective equal to current objective, which would be the one we found. The reason we need two separate ones for if a quest is one objective long or more is because if we used objectives in quest count -1 is equal to 0, well, so it'd be equal to 0, and at the same time, even if we hadn't completed the objective, it starts at 0. So it would automatically complete the quest, even if it wasn't. So that is why we need two different cases for that. And again, if current objective is null, we couldn't find the objective. And otherwise, if our array of strings that we split up at the start, so if that is more than 2 elements long, we've got IDs that are needed. So we will pass in that using the passIn IDs method. And then we will finally add this quest to the active quests list in the quest display.gui.me add active quests to add. And yeah, sorry for that garbled explanation. Sorry, and one last little correction. I forgot that Populate Container takes a string array, not a string. So basically, I have to call inventory data.split and call it with the serialization controller.me.split, which is just a semicolon stored in a char array. And yeah, that is pretty much it for serialization. So that has been a fucking pain in the ass, but it was kind of one of the most important things about an RPG, because you need to store all that data and then be able to recreate the world, and that is all very hard. So congratulations if you've made it this far. You should feel proud of yourself for listening to me ramble, and even more so if you understood it. So yeah, that's pretty much it. Go check out all the shit in the description. If I missed something completely fucking obvious, I fucked up somehow, or you don't understand anything or whatever, just wing us a comment and I will answer it to the best of my ability. What else? Yeah, go buy Loud or Quiet and shit. That is on Steam now. It had a brief reduction in price because I thought it was a bit high, and hopefully that'll make it sell a bit better. Got one sale today from Russia, apparently, so that was nice. Yeah, what else? Go check out the Ludum Dare entry I did, and sorry for the gap last week. I wanted to celebrate Christmas, my birthday, and New Year's by getting pissed. So, and unfortunately, I think my birthday fell on a Wednesday, so I was busy going to see Star Wars, which was all right with Ben Swallow, was it? Fucking ridiculous, but whatever. So yeah, cheers for watching. Like, comment, subscribe, and goodbye.